process is a bit detailed, so make sure that you take careful notes. I always use 2 columns. I'll do the main problem here. I'll do a bunch of scratch work here. Okay? U-substitution generally only works. There are some exceptions, but most of the time it's only going to work when you can identify 2 functions that are being multiplied. So as I look at this, I can see 2 functions being multiplied as long as I kind of re-envision the problem as this. Okay, so I see 2 functions being multiplied. And for U-substitution to work, that's generally what I need. There will be some exceptions in the future, but generally 2 functions multiplying. Actually, what I have here is I have 3 functions. I've got this function, I've got a constant 9, and then this function, and then the dx. So because 9 is a constant multiplying factor, that can come out. Put the 9 out front. Okay, so 2 multiplying functions is the key to U-substitution most of the time. Questions? There will be some exceptions, but don't worry about those yet. Once you get good at U-substitution, handling the exception is easy. Okay, you have to look at the 2 functions and identify that they are of a specific form. The forms match pretty close to what you see on this sheet. The first one here, x to the n, one of the forms you're going to encounter is something to a number. Like you're looking at these 2 functions, these 2 multiplying functions, and you're asking yourself, is this something to a power? Yeah, I guess if it's all of it to the first. But it's better seen as being 1 over something. So that's the form of this first multiplying function, 1 over something. The second multiplying function is e to the something. Okay, the process is called U-substitution because we are literally going to transform this antiderivative, which only uses the variable x, into a brand new antiderivative problem that will only use the variable u. So we're going to make replacements. So first step, 2 multiplying functions. Figure out what form they are. This one is 1 over something. This function is e to the something. The choice for u is always the something. So in this case, because I have e to the something, my choice of u would be 3x. In this case, because I have 1 over something, my choice of u would be e to the 3x plus 3. Question? U-substitution is one of those processes in this class that you really don't have to know the why. You just have to know how to do it. So as long as you can look at the problem and say, okay, 2 multiplying functions, this is 1 over something, so that's one possibility. U is always the something. E to the something, u is always the something. Whenever I start saying u is always the something, last year Ellie Lysenko and Mikkel Dahl reminded me that it sounded like the movie The Help. You've seen the movie The Help? No, yes? It's a really good movie. Where the house, yeah, there you go, Cassidy knows. Yes, you got over here to see. U is kind, U is smart, U is important, U is e to the 3x plus 3. Okay. Yeah. All right. The movie's way better than the joke. Okay. Questions? Okay, next step. You don't use both choices. Like U cannot equal 2 different things. That doesn't make sense. So only one of them will work. Here's how you figure out which one works. Start with the simpler. Just say it out loud, please. What's the derivative of 3x? 3. For U-substitution to work properly, this 3x came from this multiplying function. The derivative of my something should be the other function. And it is not. So that's not going to work. So instead we'll work with the more complicated one. So we take the derivative of both sides. So d over dx of u and d over dx of this thing. So write that down. So now we have to remember the derivative rules. So this becomes du over dx. The derivative of e to the something is e to that same something multiplied by derivative of the something. The derivative of 3 would be 0. Questions?
Why is it plus 0?
Because the derivative of 3 alone would be 0. Good question. 2 points. So now we have du dx equals 3e to the 3x. So I probably sound a little repetitive, but you start by identifying two multiplying functions. You identify the form, 1 over something, u becomes the something. E to the something, u becomes the something. The derivative of the something should be the other function. So because this something came from here, the derivative of this something is supposed to be this, but it isn't. This one's much better. This something came from here, so the derivative of this something is supposed to be this. Well, e to the 3x and 3e to the 3x are the same function, except for this multiplier is 1, this multiplier is 3. You don't have to worry about the multiplying coefficient. It's going to factor out anyway. So that's a match. That's good news. Please.
So what would happen if that one wasn't a match either?
So if neither one matched, what that means is you may have made a mistake in picking u. So that's just an error. You got to go back and find out why. But it's also very possible that you have hit a problem where U-substitution won't work. And the other method you'll likely use is some sort of algebra. We'll practice that in the future, but that's really the only possibilities. You've either made a mistake, or it's algebra, or maybe one of the formulas actually did work and you just didn't notice it. Good question. Important. So like I say, that's good news for this class. Like in Calc 2, you have to go searching for, well, maybe I'm supposed to use this technique. And like you asked earlier, Sage, like why isn't it just easy to go backwards? And I don't have a great answer other than it isn't. And the techniques you learn are just far more complicated. So, okay. It's going to work, so now we start substituting. So this becomes 9 antiderivative of 1 over u. You're just using the equal sign. It says right here, this one's wrong, cross that off. U and e to the 3x plus 3 are the same thing. So instead of writing e to the 3x plus 3, I write u. I need something to substitute for e to the 3x dx, because I want to change everything from x to u. So look over here. This is du divided by dx. That means we can multiply both sides by dx. Question? Cool. trying to replace e to the 3x dx. One of you will see it. What can I do here to figure out what e to the 3x dx is the same as? So I can make a replacement. It's called substitution.
Divide by 3.
Divide both sides by 3. So this side becomes 1/3 times du. This side becomes e to the 3x dx. And now I know that e to the 3x dx is exactly the same thing as 1/3 du. That's why I said the 3 doesn't really matter. You're going to move it anyway. So that's a perfect replacement. So I go like this. The whole idea of U-substitution is start with something complicated, change to something easy. Question? These are just 3 factors being multiplied. This factor is a constant, so it can factor out. 9 multiplied by 1/3 is 3. Questions? Please, go.
So what's it 1 over? Because in the original we did 1, we chose the e 3x plus 3.
So what we did originally is we said, hey, these are the 2 functions that are multiplying.
Yeah.
This one is of the form 1 over something. And just like the movie, u is something. U is special, u is kind, u is something. So my accent isn't very good. So questions? I thought about teaching this topic as W substitution, but it's not nearly as interesting. It's not catchy. You know? W it doesn't work. So never mind. Tough day at the office. Okay. Questions here? Now use the pink sheet. No groaning. You're very convincing. It's just the 3rd rule down on the left. It's just the ln rule. It says the antiderivative of 1 over u is just the natural log of u. You're done. You always finish with the pink sheet. Pink sheet's always the last step. And now we just note that u is e to the 3x plus 3. Question? Other than expressing distaste for the whole process.
Wait, so is the answer 3 times the ln of u or 3 times the ln of natural?
Technically, they're the same answer because u and e to the 3x plus 3 are the same thing. But on the AP test, you have to write this, or you will lose a point. They're testing to see if you understand that the instructions up here were, one second, fellas, sorry. The instructions up here were, find the antiderivative in terms of x. You can't find the antiderivative in terms of u. So we stop here, put a plus c on it. 2 points. Anybody else? Oh, please.
What happened to the du? Like, where did that?
So that's what I was saying to Lily. The way I think it's best to think about it for our class, like it's just good enough. I'm not saying this is a real technical explanation. Is this idea I did earlier, where if you're finding the square root of 16, you say this is 4, and we just say, well, we did what the square root asked us to do.
Okay, so it's the same.
Yeah, same idea. These 2 symbols are telling us, find the antiderivative of this.
Okay.
The pink sheet says antiderivative of this is this, so we've done it. So
Okay.
is that
Yeah.
2 points?
So du, it's not the same thing as dx, but like it kind of.
All it, think of it this way. If you have a problem where all the variables are t, it's no different than if all the variables are x. So here all the variables are u.
Okay.
Here they're all x. U-substitution to me feels kind of like black magic. Because you're like, what? You like just do some weird stuff and then you have an answer? That's how it feels to me, like weird. So for our class, you don't need to stress about it. It's just a technique that works really well. And as long as you learn the technique, you're fine. They do test you on it. Like it's worth about 10 points on the AP test. Like it shows up here and there.
So is like the reason that we can use the ln rule because we switched we substituted u for x.
Another way to think of it, honestly, is somebody, like you could come up with a rule that would fit this. Like if you go to a textbook, they have what are known as integral tables, antiderivative tables, and they're like pages and pages of this stuff. Like I have a book in the back that has like 100 pages of formulas that look just like this. One of them looks like this, I guarantee you. And if you just look up the formula, you just plug it in and you're done. U-substitution is simply a technique to avoid having to memorize so much. So it's just a way of kind of manipulating the symbols to get the formula to work.
Kind of black magic.
It's black magic. Yeah, it does feel black magic to me. But again, if you just learn the steps, it's really not that bad. So 2 points for Kate. Did I answer your question, Kate?
Yeah.
Okay. Cassidy, have I answered your question, Kate?
Yeah, probably.
Yeah, I do.
I can't remember.
Yeah, it's all good. Sage, you good? Okay. Anybody else? I just didn't want to make sure I forgot somebody. Let's do another one. Here we go. Yeah, why not? Oh, one last thing I forgot to mention. Look here. Look here. On the back of the answer sheet, if you look up the answer to 24, I believe there are no absolute value bars. There are none, or there are? There are not, correct?
They're like this.
Yeah, parentheses.
Yeah.
Curved absolute value bars. Seems like they curved them. It's all good. Sorry, 2 points for Sage. Sorry, Sage. That was a little mean, I'm sorry. Look up. There's a reason why they threw away the absolute value bars. You would know? Ella. Close. Just change the wording a little. Let me say it back to you. So E is 2.7-ish. So it's not E that's the reason, but you're close. E to an exponent, you all need to memorize. E to an exponent is always positive. You have to get that memorized. It shows up on the test all the time. E to an exponent is always positive. Adding 3, still positive. Absolute value of a positive doesn't do a thing. So this particular problem does not need the bars. Others will, but this one doesn't.
So you just keep them there, or leave it done?
I believe on an FRQ they will not take away points. On a multiple choice, you've got to recognize that they probably won't be there. But they won't have two answers. Like one of them won't have the bars and the other one not, because those are the same answers. So anyway, I was just explaining because I've had people in the past come back and say, what happened to the bars? So, and then don't forget, bless you. Joke somewhere. Okay, next one.